Hello students, welcome to my YouTube channel and welcome to the topic of differential equation. In this particular video session, just we are going to discuss about the short type questions of the chapter differential equation from the last 10 years annual exam, that means from the CHSE 2014 to the 2023, that means the previous year. So let us start the video from the first question, and here we are going to discuss about only short type questions. That means just we are going to discuss about those type of questions which carry 3 marks or 4 marks from the last 10 years annual exam. So here it is the first question, and the given differential equation is in the form of x log x dy upon dx plus y is equal to log x. So first of all we have to simplify this. It will be dy by dx plus 1 upon x multiplied with log x multiplied with y. It is log x divided by x log x. Just I have divided x log x to each and every term, both in the left hand side and in the right hand side. Then it will be dy upon dx plus 1 upon x dot log x into y. It is 1 upon x, and this is a linear differential equation. It is in the form of dy upon dx plus p of x into y is equal to q of x. Here p of x is equal to 1 upon x multiplied with log x. So integrating factor will be e to the power integral of p of x dx. It will be integral of 1 upon x dot log x. Taking log x, let log x is equal to t, then 1 upon x dx, it is dt. So it will be e to the power integral of 1 by t dt. Then it is log t. Then it will be e to the power log t, it is t, that means it is log x. So integrating factor is equal to log x. Then we have to multiply this integrating factor to the both sides of equation 1. Multiplying the integrating factor to the both sides of equation 1, we have it is log x multiplied with dy upon dx plus 1 upon x into y. Log x and this log x got cancelled. Then it is 1 upon x multiplied with log x. Then it will be differentiation of log x into y, and this is log x divided by x. Integrating both sides. Integrating both sides, we have, it will be log x multiplied with y. It is log x divided by x dx. Let log x is equal to t, and again 1 upon x dx, it is dt. It is y dot log x, it is t dt. Then it will be t square by 2 plus c. In place of t we can write down log x. So y dot log x. Hence it is the required solution. Then the problem number 2. It is in the form of variable separable method. So it will be e to the power 3x multiplied with e to the power 4y. Then it will be e to the power minus 4y dy. It is e to the power 3x dx. Integrating both sides, we have then it will be e to the power minus 4y divided by minus 4. It is e to the power 3x divided by 3 plus c plus c1. Consider the constant as c1. Then it will be e to the power 3x divided by 3 plus e to the power minus 4y divided by 4 plus c1. Just I have shifted this term towards the right hand side. So it will be e to the power 3x divided by 3 plus e to the power minus 4y divided by 4 plus c1 is equal to 0. Taking the LCM as 12, it will be 4 e to the power 3x plus 3 e to the power minus 4y plus 12 c1 is equal to 0. Then it is 4 e to the power 3x plus 3 e to the power minus 4y plus 12 c1 is equal to 0. Just multiplying 12 with 0 as the cross multiplication. Then it will be 4 e to the power 3x plus 3 e to the power minus 4y plus c is equal to 0. Here 12 c1 is equal to c, and this is the required solution. Then going to the problem number 3. Then going to the problem number 3. It is dy upon dx is equal to 2x multiplied with sec y. It is again in the variable separable form. So it will be dy divided by sec y is equal to 2x dx. Integrating both sides, we have, okay, it can be expressed in the form of cos y dy, and it is 2x dx. Integrating both sides, we have, then it will be sin y, it is 2 into x square divided by 2 plus any constant c. Then it will be sin y is equal to x square plus c, which is the required answer. Then moving to the problem number 4. It is very much similar to question number 2, because it can be converted into the form of dy upon dx is equal to e to the power 3x plus 4y, and just we have solved this problem a little while ago, which is question number 2. So no need to solve it again, and here it is the question number 4. Then moving to the question number 5. So here it is the question number 5. It is a Bernoulli's equation. So let us solve it. First of all, we have to convert it into the form of the Bernoulli's equation. So it will be dy upon dx plus 1 upon x into y square into ln x divided by x. Then again dividing y square to both sides, we have 1 upon y square dy upon dx plus 1 upon x into 1 upon y. Then it is ln x divided by x, and it is a Bernoulli's equation. Let 1 upon y is equal to z minus 1 upon y square dy upon dx. It is dz upon dx. Then it is 1 upon y square dy upon dx. It is minus dz upon dx. So it will be minus dz upon dx plus 1 upon x into z. It is ln x divided by x. Then multiplying a minus 1 to both sides, we have dz upon dx plus minus 1 upon x into z minus ln x divided by x it is a linear differential equation. It is in the form of dy upon dx plus p of x into y is equal to q of x. Here p of x is equal to minus 1 upon x. Then integrating factor will be e to the power integral of e to the power p of x dx. Then it will be e to the power minus ln x, that means e to the power ln x to the power minus 1, that implies x to the power minus 1, that implies 1 upon x. Then we have to multiply this integrating factor to both sides of the linear differential equation. Multiplying the integrating factor to both sides of equation 2, we have 1 upon x dz upon dx plus minus 1 upon x square multiplied with z minus ln x divided by x square. Then it can be expressed in the form of derivative of 1 upon x multiplied with z, and it will be minus ln x divided by x square. Integrating both sides, we have it is 1 upon x multiplied with z minus integral of ln x divided by x square dx. Then it will be 1 upon x into z, it is minus ln x multiplied with 1 upon x square dx. Here first function is equal to ln x, second function it is 1 upon x square. So by using the integration by parts method here, we have then it will be minus ln x, integral of 1 upon x square, it is minus 1 upon x, minus derivative of ln x, it is 1 upon x, integral of 1 upon x square, it is minus 1 upon x dx. Then simplifying this step, we have, it will be minus minus plus, so it will be ln x divided by x minus minus plus minus minus integral of 1 upon x square dx, and here it is 1 by x into z in the left hand side, then it will be 1 upon x into z, it is ln x divided by x minus integral of 1 upon x square, it is minus 1 upon x plus any constant c. Then it will be 1 upon x into z, it is ln x divided by x plus 1 upon x plus c. Then 1 upon x into z, it will be ln x plus 1 plus cx. In place of z, we can put 1 upon y, so it is ln x plus 1 plus cx. Then 1 is equal to y multiplied with ln x plus 1 plus cx. And here it is the required answer. Then going through the next problem. Here it is the next question, question number 6. It is given that we have to form a differential equation from this equation. Y is equal to a multiplied with e to the power 3x plus b multiplied with e to the power 5x. Consider this as equation number 1. If y is equal to this much, then dy upon dx, it is 3a e to the power 3x plus 5b e to the power 5x. It is the equation number 2. Then d square y upon dx square, it is 9a e to the power 3x plus 25b e to the power 5x. It is the equation number 3. Then we have to solve equation number 2 and equation number 3. Solving equation 2 and equation 3, we have 5 multiplied with equation 2, it is 5 dy upon dx, it is 15a e to the power 3x plus 25b e to the power 5x. Then equation number 3, it is d square y upon dx square, it is 9a e to the power 3x plus 25b e to the power 5x. Then it is 5 dy upon dx minus d square y upon dx square, it is 6a e to the power 3x. Then it is 1 by 6 multiplied with 5 dy upon dx minus d square y upon dx square, it is a e to the power 3x. So here it is the value of a multiplied with e to the power 3x. Similarly, so here it is the value of a into e to the power 3x. Similarly, again solving equation 2 and 3, we can have b into e to the power 5x is equal to 1 by 10 into d square y upon dx square minus 3 dy upon dx. And you have to prove it. From equation 1, we have, here it is the equation 1, y is equal to a into e to the power 3x plus b into e to the power 5x. And then here, by putting these values, 1 upon 6 multiplied with 5 dy upon dx minus d square y upon dx square plus 1 upon 10 multiplied with d square y upon dx square minus 3 dy upon dx. And then solve it. The final answer will be, after solving this, you will have d square y upon dx square minus 8 dy upon dx plus 15y is equal to 0. And this is the answer. It is the required differential equation. Then going through the next problem. Here it is the question number 7. Then it will be dy divided by y square minus 6y plus 5. It is just of the form, variable separable form. Then it will be dx divided by x square plus 7x plus 12 is equal to 0. Then it will be 1 upon y minus 5 multiplied with y minus 1 dy plus 1 upon x plus 4 into x plus 3 dx is equal to 0. Then integrating both sides, we have it is ln c. Then it will be 1 by 4 integral of 1 upon y minus 5 minus 1 upon y minus 1 dy plus integral of 1 upon x plus 3 minus 1 upon x plus 4 dx. It is ln c. Then it will be 1 upon 4 integral of 1 upon y minus 5 dy minus 1 upon y minus 1 dy plus integral of 1 upon x plus 3 dx minus 1 upon x plus 4 dx. Then it will be 1 upon 4 ln y minus 5 minus ln y minus 1 plus integral of 1 upon x plus 3, it is ln modulus of x plus 3 minus ln modulus of x plus 4, it is ln c. Then multiplying a 4 to both left side and right hand side, we have multiplying a 4 to left hand side and right hand side. Here the 4 will be cancelled. So it will be ln modulus of y minus 5 minus ln modulus of y minus 1. Then it will be 4 ln modulus of x plus 3 minus 4 ln modulus of x plus 4. Then it will be 4 ln c. Then simplifying, it is ln y minus 5 minus ln modulus of y minus 1 plus ln modulus of x plus 3 whole to the power 4 minus ln modulus of x plus 4 whole to the power 4, it is c, ln c. For ln c, consider this constant as ln c1, 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 4 ln c1, so that it will be ln c, another constant. Consider 4 ln c1 as ln c, another constant. Then simplifying, we can have ln y minus 5, then here it is a positive sign, so multiplied with x plus 3 to the power 4 divided by y minus 1, and here it is a minus sign, so it is x plus 4 whole to the power 4 by applying the properties of logarithm, it is ln c. And so the final answer will be y minus 5 multiplied with x plus 3 whole to the power 4, y minus 1 whole x plus 4 whole to the power 4 as c. And here it is the answer. Then going to the next problem. So here it is the next question. The given equation is y is equal to a sin t plus b e to the power t, and we have to form a differential equation by using this given equation. As there exist two constants, so first of all we have to find out the differentiation two times. That means up to the second order differentiation. The first order differentiation dy upon dt, as the variable is t, so dy upon dt it is a cos t plus b e to the power t. And after the second differentiation, again we can have d square y upon dt square, it is minus a sin t plus b e to the power t, and which is equation number 3. Then adding the equation 1 and equation 2, we have just got here b e to the power t, b multiplied with e to the power t, and b e to the power t is equal to y plus d square y upon dt square whole divided by 2. Then from equation 1 we have a sin t is equal to y minus b e to the power t, and in place of b e to the power t we can put this value here. Then by solving we can have a sin t is equal to y minus d square y upon dt square whole divided by 2. Then from equation 2 we can have a cos t is equal to dy upon dt minus b e to the power t, and again in place of b e to the power t we can put the value, because from equation 2 we can have a cos t is equal to dy upon dt minus b e to the power t, and in place of b e to the power t we have this value. Then by solving, we can have a cos t is equal to 2 dy upon dt minus y minus d square y upon dt square whole divided by 2. After the evaluation of a sin t and a cos t, now we have a cos t divided by a sin t. It will be 2 dy upon dt minus y minus d square y upon dt square whole divided by, this will be y minus d square y upon dt square. Both of the 2's in the denominator got cancelled with each other. Then it will be cot t is equal to 2 dy upon dt minus y minus d square y divided by dt square whole divided by y minus d square y upon dt square. Then it is cot t multiplied with y minus d square y upon dt square. It is 2 dy upon dt minus y minus d square y upon dt square. Then solve it, and these are the types for you. Final answer will be cot t minus 1 d square y upon dt plus d 2 dy upon dt minus cot t plus 1 into y is equal to 0. So here it is the required differential equation. Then going to the next problem. So here it is the next question, question number 9, dx upon dy plus 1 upon y, 1 plus y square multiplied with x is equal to e to the power minus tan inverse y whole divided by 1 plus y square. Consider this as equation number 1, and it is a linear differential equation. It is in the form of dx upon dy plus p of y into x is equal to q of y. Here p of y is equal to 1 upon 1 plus y square. Integrating factor is equal to e to the power integral of p of y dy. It is e to the power 1 upon 1 plus y square dy. Then it is e to the power tan inverse y. So it is the integrating factor. Then we have to multiply this integrating factor to the equation number 1, that is linear differential equation. Multiplying the integrating factor to the both sides of equation 1, we have, it is e to the power tan inverse y into dx upon dy plus e to the power tan inverse y into 1 upon 1 plus y square into x. Then it is e to the power minus tan inverse y multiplied with e to the power tan inverse y whole divided by 1 plus y square. Then it is the differentiation of e to the power tan inverse y multiplied with x is equal to 1 upon 1 plus y square. Multiplication of these two terms is equal to 1. Integrating both sides, we have, it is e to the power tan inverse y into x then it will be e to the power tan inverse y into x is equal to tan inverse y plus c. Then it is x is equal to e to the power minus tan inverse y multiplied with tan inverse y plus c into e to the power minus tan inverse y, and here it is the required solution. It is the required solution. Then going to the next problem. So here it is the question number 10. It can be written in the form of dx upon dy is equal to x upon y plus 2yq upon y. Then it is dx upon dy plus minus 1 upon x into y is equal to 2y square. And here it is the equation number 1. It is in the form of, it is a linear differential equation. It is in the form of dx upon dy plus p of y into x is equal to q of y. Here p of y is equal to, there is a mistake, it is y and it is x. So here p of y is equal to minus 1 upon y. Integrating factor is equal to e to the integral of p of y dy. So e to the power minus integral of 1 upon y dy. It is minus ln y. So it is e to the power ln y to the power minus 1. Then it is y to the power minus 1, and that is 1 upon y. Then we have to multiply this integrating factor to the equation number 1. Multiplying the integrating factor to the both sides of equation 1, we have, it is 1 upon y dx upon dy plus minus 1 upon y square into x, it is 2y square divided by y. Then it can be reduced into the form of differentiation of 1 upon y into x, and it is 2y. Integrating both sides, we have, it is 1 upon y into x, it is integral of 2y dy. Then it is 1 upon y into x, it is 2y square divided by 2 plus c. Then it is 1 upon y into x, it is y square plus c. Then x is equal to yq plus cy, and it is the required solution. Then going to the next problem. So here these are the problem number 11 and problem number 12. These are the very easy problems. So I am going to skip them after some steps. So it can be written in the form of d square y upon dx square is equal to x into sin x. So it is a differential equation. It is a differential equation of order 2. And we have to integrate it 2 times, and we have to convert it into the form of p by considering, here you have to consider dy upon dx is equal to p, and then again we have to integrate it, so find out the answer. Hence similarly in the problem number 12, it will be in the form of y into e to the power y dy plus x sin x dx is equal to c, and it is a variable separable form, and we have to integrate it only one time. So we have to integrate it. In both of the cases, we have to apply the by parts formula. Here we have to apply the by parts formula, and again here we have to again apply the by parts formula, and the result will be here. So here these are the very easy problems, simple problems. So I am going to skip them and next going to the problem number 13. So here it is the question number 2 and it has been asked to find out the particular solution of the differential equation d square y upon dx square is equal to 6x. It is a differential equation of the order 2. So first of all we have to write down the given differential equation and again there is a condition. It is given that when x is equal to 0, y is equal to 1 and dy upon dx is equal to 2. So by converting d square y upon dx square into the form of dp upon dx, by considering dy upon dx as p, it will be in the form of dp upon dx is equal to 6x. d square y upon dx square can be expressed in the form of d upon dx or derivative of dy upon dx. It is 6x. So integrating both sides here we can have p is equal to 6x square by 2 plus n constant c. Again in place of p we can put dy upon dx, then it will be 3x square plus c. We know that when x is equal to 0 then dy upon dx is equal to 2. So by putting these values here, x is equal to 0 and dy upon dx is equal to 2, we can have c is equal to 2. Then again integrating equation 1 we have, it will be y is equal to 3x cube by 3 plus cx plus any constant c1. Then it will be y is equal to x cube plus cx plus c1. It is the equation number 2. When x is equal to 0 then y is equal to 1. That means by putting these values here c1 is equal to 1. So the required particular solution is y is equal to x cube plus 6cx plus c1 and again we have to put these values. In place of c we can put 2, in place of c1 we can put 1. So it is the required solution. And here it is the problem number 13. Then going to the next problem. And here these are the next 3 problems, again belongs to the linear differential equation. Here it is the question number 14, x square minus 1 multiplied with dy upon dx plus 2xy is equal to 1. And it can be converted into this form, and which is a linear differential equation. And here it is in the form of dy upon dx plus p of x into y is equal to q of x. And here p of x is equal to 2x divided by x square minus 1. And then you have to find out the integrating factor, and then multiplying the integrating factor you have to solve it. Multiplying the integrating factor to the both sides of equation number 1, and then you have to integrate both the sides. Then the question number 15, again it is from the linear differential equation part. It is in the form of dx upon dy plus p of y into x is equal to q of y. And here p of y is equal to minus 1 upon y. And then you have to find out the integrating factor, and then you have to multiply the integrating factor to the both sides of equation 1, and then we have to integrate it. And the question number 16, it is very much easy, and it is from the variable separable method, and this is the given question, and it can be converted into this form, and you can see that both of the variables are separated now from each other, and then you have to integrate this side and this side, and the result will be there. And so here these are the very easy problems, and then moving to the question number 17, 18 and 19. So here these are the last 3 questions. Question number 17, and here it is the given question, and we can express this it in the form of a given differential equation, and you can see that this is exactly equal to the question number 9, just we have solved it. So no need to solve it further. Then the question number 18, it is a differential equation. We can express this question or the given problem into the form of dy upon dx is equal to y minus x divided by y plus x. And it is a homogeneous differential equation. And here we have to consider let y is equal to vx. And then already we have discussed it or solved it in our exercise part of your book. So just this is the task for you, solve it. Already we have done this. So no need to write down it further. Just question number 19. Here it is ax square plus by plus 1. This is the given equation. Just differentiating both sides, we have 2ax plus b into dy upon dx is equal to 0. Then solving it, simplifying, or we can say that dividing a b to the both sides, left hand side and right hand side, we have 2a divided by b. We have divided b and as well as x. So it will be 2a by b plus 1 upon x into dy upon dx is equal to 0. Again we have to differentiate this equation with respect to the x. Then the differentiation of 2a divided by b is 0 because it is a constant. Then here we have to apply the product rule. So it will be minus 1 upon x square dy upon dx plus 1 upon x into d square upon dx square, and then just by simplifying we can have x d square y upon dx square minus dy upon dx is equal to 0 by taking the LCM here. So here these are all the 19 questions, 19 number of questions from the last 10-year annual exam of the differential equation as the short type questions. So today in this particular video session, just we have discussed about the short type questions of the topic differential equation from the last 10-year CHSE annual exam, that is from the year 2014 up to the year 2023. In the next video session, just we are going to discuss about some of the more short type questions from the different topic. Till then, thank you.